So let's continue with the properties of logarithms. Instead of expanding things, we're going to kind of contract things. We're going to start out with these logarithmic expressions and try and write them with just a single logarithmic expression. So we're going to be going backwards. So looking here, for instance, going backwards would mean starting out by rewriting the sum of the logs as the log of a product. And then when we have the difference of logs, you can write that as a quotient. And then this is just gravy. If you rewrote x to the 1/7 as the 7th root of x, I like seeing that. It's not necessary to get it right. But let's work on a few problems, starting with kind of the first one in example D, which is 2 log of k plus 1/2 log of m. Now I've got my own little stick for working on these things. Let's see if you guys can catch on to it. 2 times log of k plus 1/2 times log of m. If you look at your properties for logs, this right-hand side is what we're going to be working with. Both of these have coefficients of 1 or -1. So I want to get to that point. In fact, I think the easiest thing to do is to try and rewrite things so that they have a coefficient of 1, and then you can use your product rule in kind of a reverse direction. What do I mean by that? Well, let's get rid of these numbers here. So I'm going to have to use my reverse parachute rule here. These numbers come up and they're exponents now. So it's going to be log of k squared plus log of m to the 1/2. Beautiful. That's exactly what I wanted. And I can further simplify this. I can use my product rule in the opposite direction. So the sum of the logs becomes the log of a product. So what would that look like? Log of what? Anyone?
K squared, square root of m.
Oh, nice. Showing off there. K squared m to the 1/2, or to quote you directly, k squared times the square root of m, because m to the 1/2 is the square root of m. Well done. Bonus points for Pfeiffer. Nice, nice. I like that one. So our trick in a lot of these things is going to be to get rid of these coefficients so we have a coefficient of 1, and then we can use our product rule. We did something like this at the very beginning of the first part of this video when we expanded something, and let's see, where can I find it? Yeah, right here. Log of 7xyz was all this. So when you have the sum of the logs, and notice all the coefficients are 1, that becomes the log of a product. This is kind of an important property, being able to start from something like this and crunch it all down to here. So let me give you one like that to try, just to practice that one. So going a little bit off script here. All right, so try and rewrite this one with one logarithmic term. First person to laugh gets a stamp of intellectual nobility on their head. Carl doesn't find it that funny. No one else getting it? All right, Marcellus is like, oh man, that's a dad joke if there ever was one. Log of cabin, yay. So if you follow me up to calculus, I got an extension of this joke too. It's pretty cool, but you have to follow me for a little ways to get there. All right, log of cabin. Anyways, the point is, when you have the sum of the logs, it becomes a log of a product. And we're going to use this idea a lot. All right, it's going to be very helpful. So let me keep going with some of the other ones. So let me start out with this one down below. So minus 5 log of x minus 8 log of y plus log of z. Now what helped us out on the last one was that we had coefficient of 1 in front of all our terms, and then we just brought it together as a product. I don't have that yet because both of these have coefficients. One of them is -5, one of them is -8. So where I might be a little bit different than my colleagues is this. I'm going to take that whole term and put it in the exponent, and that in the exponent. So it's going to look like this, equals log of x to the -5 plus log of y to the -8 plus log of z.
Is that not the normal way we don't sum?
I don't know if my colleagues take the negatives as well. I think they would just take the 5 and then factor out the negative and then have to use the quotient rule. It becomes a little bit messier. The way I'm showing you is kind of the way I think is most expeditious. I mean, it's probably the fastest way to get through this problem and the most efficient. Now, this is what we just did. This is our log cabin stuff, right? It's the sum of all these logarithmic terms. So what does that become? It becomes a log of what? Yeah, perfect. Now I think that you probably get full credit on WebAssign for that. Kiana?
So, to not get the -8 confused with a minus sign, do the quotient rule first, right?
You could rework this with the quotient rule. I avoided the quotient rule because I took the negative and the 5 and the negative and the 8 up into the exponent. So that left a +1 here and a +1 there. So I didn't have to deal with the quotient rule. I can go back and do this with the quotient rule if you'd like. Maybe I will. But there's one last step that I'll ask you for on my exams. WebAssign might be happy with that. They go, okay, yeah, you've got this written with a single logarithmic term. So WebAssign might say, hey, we're good. But I'm going to ask that you write this without negative exponents. So what happens with x to the -5th, y to the -8th? Yeah, they can go into the denominator. So again, kind of the fast way is just to put them into the denominator like this, and then z is left in the numerator. So there you go. So we avoided the quotient rule. Now, I think I see a little curiosity. It's like, well, what would this look like with the quotient rule? Well, okay, we can do it with the quotient rule. So let's revisit this, and then you tell me. Maybe I'm deluding myself thinking that I got a better method. So -5 log of x minus 8 log of y plus log of z. If I wanted to do this with the quotient rule, I would just factor out or take out the 5, so it's minus log of x to the 5th minus log of y to the 8th plus log of z. Okay. And then, well, let me reorder things. I'll do that as log of z minus log of x to the 5th minus log of y to the 8th. And notice that both of these are negative. So I can factor out the negative there. Log of z minus log of x to the 5th plus log of y to the 8th. This now is the sum of logarithmic terms. So it's log of z minus log of x to the 5th, y to the 8th, like that. I didn't really need the parentheses there. So That's fine. Let's get rid of them. But now I've got the log of something minus a log of something else. Now I can use the quotient rule. So it's log of z over x to the 5th, y to the 8th. So that's what it would look like using the quotient rule. I mean, the steps are there. It's nothing that we haven't seen in terms of our properties of logs, but I don't know. You tell me. Like the first one or the second one? Which one resonates with you? Which one? First one? Good answer. Good answer. All right. Bonus points for everybody all around. Nice, nice. Well, let's see if we can't do that with this third one down here. And that is, let's see, let me get. So it's minus 9 log base b of x minus 2 log base b of y plus 1/2 log base b of z. So give that one a shot. I'll walk around and try and help you out. Pick whichever of the two above methods works best for you. Try and write this with the single logarithmic term. Try and get positive exponents as well, please. What's that? It's not what goes on top, it's just the things with negatives go in the bottom.
Oh, okay.
Putting the key like this where it says.
All right. This has to be a multiplication here, it's not a addition. And I will mark that wrong. So that, no, that's good, yeah, it's not really a multiplying, it's log of that base of all of that. Nice, showing off again. All right. So, a couple ways you can do this one. I will show a little bit more detail in one little aspect, but it's going to start out like this. I'll rewrite this as log base b of x to the negative ninth plus log base b of y to the negative second plus log base b of z to the 1/2. Now there's a couple things that I saw in walking around. When you change this from the sum of the logs to the log of a product, it's going to look like this. Log base b of x to the negative ninth times, it's not a plus. If you put a plus in here, I'll be really unhappy. Times y to the negative second times z to the 1/2. So that's the next step that I expect. Now, typically I'll go from here to the answer, but just so you understand where that answer is coming from, let me show you an extra step here. I can write that as log base b of 1 over x to the ninth times 1 over y to the second times z to the 1/2. Well, that doesn't have a negative exponent, so I'll just leave that in the numerator. I can write it over 1 if I like. And when you multiply fractions together, you multiply their numerators and you multiply their denominators. Log base b of z to the 1/2 over x to the ninth, y to the second, like that. Cool. Did that little extra bit help out, Charlie?
Yeah.
Okay, good. Now, mostly I expect people to go from here to here. But if you want to show this step, or if you want to do it with the property, the quotient property, that's fine. You know, whatever works for you. This is what I'm looking for. A couple of you were showing off again, getting that square root of z there. I'm happy to see that. Occasionally I'll give some extra credit for stuff like that, but whew, there we go. Are we doing okay for example D here? Let's move on. Now, one of the things that I expect you to be able to do is to be able to calculate log base 5 of 4. Now, if you've got the fancy graphing calculators, I showed you how to do that. Let's review that real quick. There's actually a couple places you can get to that log base thing. So the first one is you hit the math key, and then personally I go up. Log base, so there you go. Log base 5 of 4. Bam, like that. 0.8613, etc. So let me write that down. 0.8613, dot, 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 dot. So not bad. If you don't have a fancy graphing calculator, then you need to use what's called the change of base formula. So that's this thing right over here, your change of base formula. Change of base formula. And I'll probably give that to you on the exam, but if you needed to calculate log of a different base, something you don't have directly on your calculator, and the only things you have directly on your calculator, at least on the face of the keys, is log base 10 and log base e. So the natural log and log base 10, or the common log. So if you wanted to calculate this kind of old school, which is what we used to have to do, then it would look like this. It'd be the log of the numerator divided by the log of the base. It's convenient to do that with base 10, so I would just do log of b divided by log of a. So in our case, it's log of 5 divided by log of 4. Log of 5. Make sure you hit the right parenthesis, divided by log of 4. And I should get the exact same thing that I just got. Ooh, no, I'm not. Oh, I mixed them up. Yeah, because it's 4's in the numerator, sorry. So let's switch that around. That should be the 5. That should be the 4. There we go. 0.8613, etc. Now, a good thing to practice for us is to be able to check this. And to be able to check this, let me rewrite it using exponents. You remember how you would rewrite this using exponents? This is exactly a perfect question for an exam. Rewrite this using exponents. What would it be equivalently using exponents? Anyone? Come on, come on. You can press the button too if you get this right. No? Not the right inducement? Oh my, oh my. Good thing you got the weekend to study, right? What to what power equals what? Remember, in general, log base a of x equals y is equivalent to a to the y power equals x. So what would that say down here? Oh, come on. I'm recording this. You're making me look bad.
5 to the 8613 equals 4.
Yeah. 5 to this power equals 4. Now, I don't really feel like typing all this number in here. That looks like kind of a pain. So here's what I'll do. Let's use some of our properties on our calculator. This number is stored in a key down here called answer. So if I do 5 to the power of that, I should get 4. Let's see what it looks like. So let me clear this out here so you can kind of follow along my keystrokes. I want to do 5 raised to the power of answer. Now answer is right above the opposite key in the bottom right of your calculator. So if you hit the second key, then this, it's going to take this number with all its precision and make it the exponent of 5. Hold your breath, drum roll please. Am I going to get 5 or 4? Bam, exactly 4. Now, if you're feeling lazy and you're like, I don't feel like doing all that, just type in the first few digits. 5 raised to the 0.8614, we'll call it. Do you think I'll get exactly 4? I should get something close enough to 4 to make me feel pretty good, though. There you go. All right, so you don't have to do it that way, but one thing I promise you, you will get is problems like this where you have to start with an expression with logarithms and get an expression in exponents. So the answer I'd be looking for here would be 5 to the 0.8613, and by this dot, 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 I mean it continues forever, equals 4. This much you should have memorized. Definitely. On the top of your test, write that down before you forget it, before you panic and go, oh my gosh, I only got 10 minutes left. Memorize. That one I'll be giving you, so if you need it, you can use it. I hope you don't need it. Let's move on down to example F here. And this is kind of a cool example of a multiple choice question, or a multiple guess question, I guess I can give you. Which pair of expressions in the list are equivalent? Are they all the same? Or none of them the same? 2 of them the same? 2? Which 2? Ah, well done. A and C. These 2 are equivalent. This one, you can't take this and turn it into this. It just isn't right. So, good job.
that was easy.
Yeah, well done, well done. I want you to try and calculate these first two here. See what you can come up with. And then maybe we can kind of try and generalize this a little bit. If you get that, try the last one, the very last one, H. See if you can do it without a calculator. You should be able to do it. Yeah, if you're not working with a TI 84 or 83 on this one, it's going to be a little bit harder. All right, I'm not sure if everyone has a graphing calculator, so let me help you out here. Let's take a look at the first one. Let me clear up some things here so you can kind of follow along. I want 7 raised to the power of log base 7 of 3. So to get to the log, I'll hit the math key, and then I go up. Log base 7 of 3. Did anyone get the answer? No one? Just one? Josh, what'd you get?
I got 3.
Bam, 3. That's interesting. Let's write that one down. So that one's going to equal 3. How about the next one? Let me show you a different way to get to that log base key. If you hit the alpha key, and I think it's the zoom key. No. How about alpha and window? Yeah, if you hit the alpha key and then the window key, that again gets you to the log base 5 or whatever menu. So I'll choose the 5th one down. Actually, you know what? I messed up. I need to start with 9 to that power. So we're going to work on this one. 9 to the log base 9 of 9. Yeah.
9.
Yeah. 9 raised to, let's see, alpha window 5. Log base 9 of 9. Personally, too many 9s in this for my flavor. I'd probably give you something more like the first one. But yeah, we get 9. So equals 9. Let's go back now and add a little formula to our problem, or our question. Alex, you having trouble finding that key on your calculator or something?
Yeah, I don't have it.
Yeah.
Oh, you have 8.
Yeah, the 84 has it, the 83 doesn't. So you're going to be stuck using the change of base formula if you needed to do those. Keep in mind, you can always just borrow one of my calculators during the exam. So, but I guess the thing that I want to put here, the additional property that I need to do in, would be this one. B to the log base b of x. So the base of your exponential function and the base of the log are the same. What am I going to get here? What should I write? X. These operations cancel each other out because they're inverse functions. Remember we did inverse functions way back when? I was really only at the start of this chapter, but that's an additional property that you can use. This one comes in handy. So these two are essentially doing and saying the same thing. They're inverse properties of each other, or they're showing you what happens when we have a function followed by its inverse. Thank you. Okay. Let's see. How about this one? Can anyone do this one in their head? What power of 4 gives me 4? 1. How about this one? Log base 4 of 4 to the 11th power. What power do I need to raise 4 to get 4 to the 11th power? 11, yeah. It almost feels circular, but that's the right answer. And the last one, altogether, 7. Yay! So let's test ourselves on this last one. Let's see if we can do it without a calculator. With a calculator, it's really easy. But can you do it without a calculator? What would you do without a calculator on this one? They don't exactly cancel. There's a couple things we can do. We can do Stephanie's approach from earlier. Tell you what, let's just use the quotient rule to start with. It's log base 3 of 1 minus log base 3 of 3. Can someone simplify the first one for me? 0. That's a 0. How about the second one? 1. So what I really get is 5 times 0 minus 1, or just negative 5. There you go. Nice. Beautiful. Beautiful. All right. The properties aren't that easy. They're not always the sexiest thing in math, but they're very useful, and we're going to need them a lot when we start working in section 11.7. So if you have some questions on it, please get some help. Come in early. Catch me in office hours. Whatever it takes.